Yes. So welcome back guys to all of you on India's largest e-learning platform Gradeup, and today we are going to start the topic flywheel, gear, cam and governor. Guys, this is the third episode of the series of HAL, and this series is totally oriented for the students who are preparing for HAL exam. So guys, let us start today's session. Hope all of you are ready for the session. Please tell me, am I properly audible and visible to all of you or not? Yes, guys. Shall we start it? Yes, guys. Fine. Good evening, guys. Actually, your comments are coming late. Sorry for that. Okay, fine. Rajat, Mohit, Velmurugan, we are starting the session. So, guys, let us start the session. So, today's topic is, my dear, the flywheel, gear, cam, and governors. But, my dear, out of all these topics, my dear, these two topics are going to be more important. And in gear also, gear train is going to be more important. So guys, I will try to cover the question from all the topics today, but if some topics are not going to be covered, then we will be covering on the next day. So let us start the questions in this. So guys, a little information about me. This is my profile. I am having nearly now 9+ years of experience, and these are many research and review paper I have written. You can search, many of them you will get in unpaid journal. These are the subject or areas of expertise. And my dear, other than that, I also take basics of project management as well as material science in ESC paper 1. So guys, now we are going to start the session. So let us see what is the first question of flywheel on your screen is this one. So be ready with this, guys. Yes, hope you guys are getting it. Just try to solve this question. I am working on your comments. Actually, I feel there is a lag in your comments. I am working on that. Yes, fine. Now I am able to see your comments. Aditya, hello. Yes. Mohit Gupta, we have started the session. So this is the very first question in front of you guys. Guys, quickly like and share the session so that others can also reach to this session, because I want a big number here so that a good competition shall be there in the session, because when number of students are more, definitely then more is the try you are going to give for the question. Yes. Remo have given the answer C. Aditya is saying B. Murli is saying C. Yes. What about others? Different students giving different answers. Yes. Entertainment is saying option B. E2 entertainment. Okay. What about others, guys? Quickly solve it. Gaurav Vajpayee is saying B. Wonderful, guys. So here it is mentioned that in a 4-stroke IC engine, the turning moment during the compression stroke is. So my dear, in the compression stroke it is going to be negative throughout, because when you are going to make for a 4-stroke IC engine, the curve is going to be like this. This one is for suction, this one is for compression, this one is for power, and this one is for exhaust. So my dear, this is how the things are covered: suction, compression, power and exhaust. So compression is completely negative. So my dear, answer is going to be B for this. Yes. In compression stroke, basically it consumes the work. Yes, definitely E2 entertainment, you are correct. Rajat, sorry, the answer is B. Hope you got the right answer, and why it is, definitely you got it. Let us move to the next question, guys. And guys, as I said, in HAL, HPCL, majority theory questions will be coming. So that's why the level of question which will be there in the exam, we must prepare with that. Okay, so there is no point in going here and there if you are particularly preparing for these kind of exams. because GATE 2022 is far away. For these exams which are going to be right now in 2021, HAL, HPCL, ESC 2021. So for these exams, objective examination, this is going to be the level of questions. So now the question is from flywheel. In case of flywheel, the maximum fluctuation of energy is the sum of maximum and minimum energies, the difference between maximum and minimum energies, ratio of maximum to minimum energy, ratio of minimum to maximum energy. It is very easy to answer, guys. Very easy to answer. Fine, wonderful, guys. Gaurav Vajpayee, Rajat, Aditya, wonderful, wonderful, guys. Quickly, quickly. Yes. Murli. Fine, guys. So yes, obviously the answer is going to be B for this, because when you are going to have the fluctuation of energy, it is going to be defined as E max minus E min, and we do not define other terms for like addition or the ratio for energy at least. This is the question which is a kind of numerical, but this is not the numerical where you require calci. You can solve this without calci. So the question is in front of you. Fine, Arun Kumar, Velmurugan, Nikhil. Yes, guys, solve this one. And guys, quickly like, share this session so that others can also join this. This is helpful for all the examination of same type. Whatever you are going to give out of these. Yes. Wonderful, guys. What about this one? First of all, this diagram is given. You must see this is pi, this is 2 pi, 3 pi and 4 pi. So first of all, yes, it is the diagram for 4-stroke IC engine for sure. It is correct one. I am just trying to help you. Now the answers are Aditya is saying D, Murli is saying D, Rajat is saying A. Let us see. Now Rajat is saying B. Okay. So dear, first statement is correct. First is not there in C, it means C is wrong. C is out. The compression stroke is 0 degree to 180 degree. So my dear, compression stroke is not from 0 degree to 180 degree. Compression stroke is going to be from 180 degree to 360 degree. So my dear, when we are going to say this, obviously when we are going to say compression stroke is 0 degree to, the compression stroke is from 0 degree to 180 degree. It is not compression, basically compression is 180 to 360 degree. So my dear, if you will go by this, this is also not correct statement. Mean torque, when you are going to find out, when we will be finding out mean torque, my dear, mean torque is always defined as, it will be 1 upon 4 pi into work done. Work done is the area, and you can see the area positive is 1 centimeter square, 25 centimeter square and 0.5 centimeter square. So it is going to be 1 upon 4 pi, and positive area is 25 plus 1, 26.5. 26.5, and negative area is going to be 2 here, 0.8 here, so and 0.5 here. So 2.8, 0.5 is 3.3. So 3.3, and you know 1 centimeter square is equals to 100. You will multiply it with this, and then you will be getting the value to be 580 upon pi. This will be the answer you will be getting, I feel so. So when you will be getting this, obviously this option is going to be a correct one for sure. So my dear, if you are going to see this, you know one option is correct and third option is correct. When they are saying it is a multi-cylinder engine, then my dear, as per we see this one, this is for given as single cylinder only. So obviously 4 shall not be correct one. If 4th is not correct one, my dear, then definitely if I have to go for D or A, then my dear, obviously the things are going to be complicated, because this type of question are generally comes in ESC, where they write tick the most appropriate one. But the similar thing is happening in, obviously, for the questions which are coming in HAL, HPCL also, as HAL was previously taking its own exam. So sometimes the options are not obviously correct, not absolutely correct. So in that case, you have to choose the most appropriate one. So my dear, obviously fourth one is wrong. If you know first is correct, if you know third is correct. So now you have either this or this. Then my dear, the point is, if you are going for 4, it is definitely not a multi-cylinder engine. But compression stroke is not 0 degree to 180 degree, it is 180 degree to basically 360 degree. It is the compressive stroke. So my dear, in that case, you need to go with the most appropriate one. So obviously you will go with D, because 2 and 3 are for sure wrong statement. Multi-cylinder engine, when we are saying, it may be that the case is multi-cylinder, but they are giving the diagram for single one. So guys, in that case, in this kind of question, you need to go with the most appropriate one. You cannot go for the exact, because the exact is not there. Okay. Yes, if it would have been 180 degree to 360 degree, then obviously the answer will become obviously A. Okay. Yes. So let us move to the next question, guys. This is the next question. If the rotating mass of a rim type of flywheel, you know, in rim type of flywheel, the complete mass is outside, and because of this, the I is going to be mr square. Okay, and yes, now it is given that another rim type of flywheel whose mean radius is half the mean radius of the former, if its mean radius is r, for the another rim type of flywheel, its mean radius is going to be r by 2. So my dear, if it is r by 2, I is going to be m r by 2 ka whole square. Now he is saying that the energy stored in the later at the same speed will be. Yes, what will be the answer? You must know about the energy. My dear, energy is going to be like, if you are going to write E, it is half I omega square. And as he is saying for the same speed, so if omega is same, then you need to tell which one will store more energy, this one or this one. And you can see here it is mr square, it is mr square upon 4. So you can give answer now very easily. Gaurav is saying C, Satish is saying C, Arun is saying C, Aditya is saying C, Murli is saying C, and yes, C is the correct one. 1/4 of the first one. Yes guys, wonderful, wonderful, wonderful. Fine. Very good. E2 entertainment, very good. Yes guys, let us move further. You guys are doing well. This time the question is this one. So this is going to be the level of HAL for HPCL. That's why technical in these exams are not very difficult. Interview plays a very important role. But this time the weightage of interview is only 15%. 85% goes to written one. So definitely it is going to be more important written exam. Okay. So guys, basically when we are going for gate, accuracy is more important. When you are going for ESC, HAL, HPCL, time management is important, because in gate time is never a concern, but ESC, HPCL, HAL, time is a big concern. Okay. Yes. So what is the value of radius of gyration of disc type of flywheel as compared to rim type of flywheel for the same diameter? So if you are having a disc type of flywheel like this, and on the other side you are having a rim type of flywheel like this. This is the rim type of flywheel. They are having the same diameter. You know that they are saying about radius of gyration. Here you know I is equals to mk square, it is equals to mr square. So k is going to be r. And here k you need to see, and I is going to be mr square by 2. So k will be r by root 2. Yes. Fine guys. So many of you have given the answer, like Aditya, Arun, E2 entertainment and Gaurav Vajpayee. The answer is going to be B. So while this shows your preparation is going on the right track for sure. Let us see the next one. This is slightly a numerical type of question, and this time I am not going to help you. This time you need to solve it. So the crank of a slider crank punching press has a mass moment of inertia of 1 kg meter square. The figure below shows the torque demand per revolution for a punching operation. If the speed is varying from 30 to 20 radian per second, what is the maximum torque demand during the punching operation? So my dear, you need to find out this maximum torque. You need to find out this maximum torque. Yes. This is the question for you guys. This is the question for you. And please see and give me the answer. I am looking at your doubts also. If any of that, I will be answering it. Yes, solve it quickly. Fine, guys. We are going to have a number of questions on this. Okay, I am hiding myself. You can see the question properly for sure. Just solve this question, guys. Just solve this. Yes, what will be the answer for this? Yes. Yes, guys. So, okay, many of you are saying the answer is going to be D. What about others? So, guys, first of all, you can find out delta E. Delta is going to be half I omega max square minus omega min square. This is going to be delta E. And my dear, you just need to put this as this is delta E. And it is given that the crank of a slider crank punching press has a mass moment of inertia of this one. The figure shows the torque demand per revolution for punching operation if the speed of the crank is found to drop. Here it is given for crank. So for sure, whatever delta E is going to be half into T into theta. That the area of the curve, delta is going to be half into area of the curve. This is going to be half into T into theta. So if you see this, the values are not... yes, fine. This is basically, this is going to be the, basically it is mentioned here that it is going to be pi by 3. So in the figure it is mentioned that the total is pi by 3. So because without this you cannot solve it. So you just need to equate this and you will be getting the answer. Dear, in general in these types of examination, calculators are not available, but still nothing can be said before they are giving this information. Okay, Remo, in the last question, what we have done is this one. So you know this is the disc type of flywheel. For this I is mk square mr square by 2. And for rim type of flywheel, I have written basically oppositely. Mr square is for the rim type. For disc type, it is mr square by 2. So obviously it is going to be r by root 2 if it is going to be r. So the answer is going to be 1 by root 2. I have written the values opposite to each other. Fine, guys. Satish sir, in final year students are eligible for, yes dear, if you will be getting your degree at the time of interview, you can surely apply. Degree means a certificate which can show that your BTech is completed. Okay, if you will be getting that, means if your exam results are coming up to that, definitely you can go for it. Fine, guys. So now solve this one. So for this, the answer will be coming out to be C after equating this. So actually this is my mistake because it was not mentioned in the figure. Otherwise you will be able to solve it. And as it is given only for crank, so I am not finding out T mean, because for crank this is only going to be the total energy. Okay. Yes. Which one of the following is a flywheel generally employed? Means out of these four, which one is using flywheel? Out of these four, which one is using flywheel, guys? Which one is using flywheel? Okay, Remo, fine dear. So don't worry, in the triangle question I have missed one data, that's why you were having some difficulty. This question, please tell me now. Fine, Aditya. Very good, Abhishek. Gaurav Vajpayee. Yes, Aditya. Wonderful. The option is going to be C for this. So punching machine is going to be the thing where flywheel is going to be used. Okay guys, wonderful, really. Satish fine, C is correct. Arun very good. Aditya very good. Gaurav Vajpayee very good. Wonderful guys, C is correct. So in a flywheel, my dear, this is a good question where it is a numerical one and it is from the design of flywheel. It is from the design of flywheel. I usually teach this part in the flywheel itself. Many student knows that the question is from peripheral speed. Yes guys, quickly solve this one. Yes. Dear, what? Why not in others? I didn't get your point. Design of flywheel. So my dear, the safe stress is given as 25.2. So sigma safe is 25.2. 25.2 meganewton per meter square. And then he is saying that, and the density is 7 gram per centimeter square. So what is the maximum peripheral speed? So my dear, V is going to be less than equals to, yes, sigma safe by rho. Do you remember this formula? Do you remember this formula guys? From this you can find out the value, but take care of units properly. Take care of units properly. Ramesh Mohan is saying answer is 60. Yes, answer is correct. Answer is correct, dear. Answer is correct. Okay, why flywheel is not used in gearbox? Dear, basically flywheel is used in general when we are going to have requirement for storing and supplying of energy, when we want energy at some particular interval. Like whenever you are going to use the punching machine, then punching machine, whenever it operates, energy is required only at the time of punching. For complete cycle time, energy is not required except punching time. So that is the way why flywheel is required. But in gearbox, when gear is going to provide the power throughout, you need to have that power to be used. So it is not required. Flywheel is required where only a small part of the cycle where energy is required. The complete energy which is given by engine will be supplied at some very small interval. Okay, Aditya is saying C. Yes, C is correct one, dear. 60 meter per second will be the answer. So V is coming out to be less than equals to 60 meter per second. So obviously this is going to be the maximum velocity. Okay, this is the next question. The given figure shows turning moment diagram of an engine. The mean speed of the prime mover is 2 pi. The mean speed of the prime mover is 2 pi radian per second. So my dear, omega mean is 2 pi radian per second. Mass moment of inertia is I, 0.1 kg meter square. Then what is the coefficient of fluctuation of energy? You need to find out the value of CS. You know CS, if you want to find out, there is a formula. CS is defined as delta omega by omega mean. And one more formula, you know, delta E is equals to I omega mean square CS. These are the way. And if you want to find out omega mean, then for that you need to first calculate the area under T theta diagram. This is a triangle given. Area of the triangle is going to be half into. This value is from 800 to 1200. So it is going to be 400. Then into it is going to be from 0 to 360. Obviously it is going to be 2 pi. So it is going to write this is the area. So it is going to be the value is going to be 800 to 1200 you are getting. So obviously this is the area. Basically it is shown like this is the value of mean torque it is given, and this is delta E given. It is delta E directly given because this is the mean torque value 800. So need not to find out the mean torque. This is directly delta E. So when you will be equating this delta E with the I omega mean square CS, you will get the value of CS. Yes. Fine, E2 entertainment. So guys, with the question I am trying to give you some wonderful concepts as well, because sometimes the questions from its looking seems to be something else, it is really something else. As from the first instant it feels to be T theta diagram, yes it is, but they have given already mean torque value as 800. If it would be 0 to 1200, then we need to find out the T mean. Okay, this is the point I wanted to tell you here. So here delta is directly mentioned, so solve it and tell me the answer. I will be giving you the right answer for this. Yes. It is asked, okay, yes, coefficient of fluctuation of energy is asked. Then CE is going to be delta E upon work done. Yes, in that case it is asked as delta E by work done. Then delta E by work done is asked. Yes, for sure. Yes guys, so what will be the answer for this? They are asking delta E by work done. Yes, find out delta E first and then work done in the cycle. Okay, so guys, I would like to say that please find out CS from this equation. Okay, they have not asked CS, but I want you to find out CS first. Just tell me the CS. What will be the value of CS from here? First tell me that. Yes. Because generally in question CS is being asked every time. So I want you to work on CS first. What are you getting CS? Yes. When you will be trying for CS, you will be writing this area. It is going to be 400 pi. You will be equating it with I omega mean square CS. Omega mean is given to you, I is given to you. You can tell me the value of CS. Yes. Because yes, this question is asking CE, but majority times the question is coming, they are asking the value of CS. So I want you to find out CS first. How you will find out CS, guys? Okay, fine. So you are getting CS because actually when I have designed the question by mistake, I have written fluctuation of energy. I have made it for coefficient of fluctuation of speed. That's why I am saying this one. Okay. Yes. Dear Remo, I am telling you about delta E. Look, if we are given a diagram like this. We are given a diagram like this, that we are having this line as one line and the diagram is given like this. Then mind this line is generally indicating the mean torque and the area above this indicates the delta E value. Okay. But if let us say we are given the complete diagram, like let us say this type of diagram is given, then you need to find out the value of T mean, and then T mean value is going to be find out using T mean to be equals to 1 upon 4 pi if it is a 4-stroke IC engine. Then you will be writing T dot d theta integration from 0 to 4 pi. Okay, then you need to find out this total area which is going to give you the work done in the cycle. Okay, but I have designed this question not for CE, I have designed it for CS, and as you are getting the answer to be 7.5%. So by mistake it was written as energy, otherwise I have designed it for the, yes, for the, so sorry Aditya, I feel your calculation mistakes are there. The answer will be 7.5% for this. Don't worry, when I will be sharing this PDF with you, I will be sharing the calculations also what I have done for you in that PDF only, so that you can correct the calculations also. Okay, let us move to the next question now. Okay. If the speed of the engine varies between 390 to 410 revolutions per minute, so you are already given delta n to be n max minus n min. So it is given as 410 minus 390. So it is going to be 20 rpm. You need to find out CS value. You need to find out CS value. Fine guys, don't worry. Find out the value of CS guys. Yes. What you will get as CS? Fine Ramesh Mohan. Okay, no issue dear. Then I will be sharing the PDF with the solution. Don't worry. Aditya is saying D. Dear, I feel I have already shared the PDF. I have already shared the PDF. Just see the Telegram channel in which you are. Gaurav Vajpayee is saying the answer is D. Yes, the answer is D. Yes, the answer is D. 0.05 is the answer. Fine. You will be doing CS to be delta n by n mean. And n mean is going to be n maximum plus n minimum by 2. So n maximum is going to be 410 plus 390 by 2. It is going to be 400. So when you will be doing 20 by 400, it is going to be 0.05. Don't worry guys, I will be sharing the solutions also as I have done earlier for you only. Yes, Mahipal Singh Chauhan, yes, I know you have given the answer for that. Remo is saying the answer is B. Remo, the answer is correct. Sorry, wrong. Please see this. The calculation I have done now in front of you. Now you cannot say it is wrong. Okay, Satish Kumar, I will be sharing the link of Telegram. Even if you see onto this into the description box, the link is already mentioned there. So you can join the Telegram channel from that. Okay. Yes, let us see the next question, guys. Yes. Flywheel absorbs energy during those periods of crank rotation when twisting moment is greater than the resisting moment, twisting moment is equal to resisting moment, twisting moment is less than resisting moment, and the load on engine falls. So flywheel absorbs the energy when, if I am showing you the 4-stroke IC engine case, you need to tell me this is the mean torque when the flywheel is going to absorb the energy. Yes. Yes, when twisting moment is greater than the resisting moment. Yes, obviously, in this time, the energy will be absorbed. So when the twisting moment is going to be greater than the resistance moment. Very good, guys. Next question. The primary function of the flywheel is? Remo, I will be sharing the Telegram channel. Okay, I am sharing it. Don't worry. I am sharing it. You give the answer for this question. I am sharing it. You can join this Telegram link. Now you got it, Remo? So the primary function of the flywheel is to limit the fluctuation of speed during each cycle, to absorb energy during these periods of then the resistant moment, to maintain constant speed of rotation to the crankshaft when the load on the engine increases, to maintain constant speed of rotation of the crankshaft when the load on the engine decreases. Yes. What will be the correct answer, guys, for this question? Fine. So guys, first of all, I would like to tell you that speed, to maintain a constant speed, this is the task of governor. This is the task of governor. And to maintain a constant torque, my dear, this is the task of flywheel. And torque is associated with the energy. So the answer is going to be B for this. To reduce the fluctuation of speed, when you are saying, dear governor is going to maintain the constant speed by changing the fuel supply. And flywheel is going to maintain the constant torque by absorbing or providing some amount of energy into that. That is the difference between flywheel and governor. Both of them are the instantaneous fluctuation control devices. One device is used to work over the internal fluctuations. Other is going to work over the external fluctuation. That is the difference basically. Let us move to the next one, guys. If the radius is doubled and the speed is reduced to half of its original value, then centrifugal force will become. You know that centrifugal force is given as mr omega square. So when you are going to double the radius and when you are going to reduce the speed to half. Yes, very easy question. Very easy question, guys. Solve this one. So guys, basically sometime in these questions things are not mentioned properly. If the things are not mentioned, then you have to do by hit and trial, obviously. So in that case, obviously there are chances of that you will be losing the marks. But in general, for ESC paper, the questions are being framed like either you will give the right answer or you will leave it. Gaurav Vajpayee is saying B, Aditya is saying B, Mandeep Kaur is saying B. So when you are going to do radius to be 2 times, omega to be half, it will be 1 by 2.5 times. B is correct for that. The flywheel of a machine having weight of 4,500 Newton. So when weight is given, you can find out mass from this. Radius of gyration is 2 meter. Has cyclic fluctuation of speed from 125 to 120 rpm. G value is given to find out the mass. Delta E you need to find out. It is going to be half I omega max square minus omega min square. Fine, guys, solve it. Solve this question, guys. The flywheel of machine, first of all, find out the mass. Mass will be 4,500 divided by 10. It is 450. And when the thing is mentioned, you basically need to find out I. You know that I is already given as mk square because radius of gyration is also given to you. So it is going to be 450 into 2 ka square. Yes. Here when you are saying mv square by r, basically when you are talking about flywheel Arun Kumar, it is a device which is having rotational kinetic energy. So when we are talking about rotational kinetic energy, then you need to consider in that sense. Okay, because they are rotating with omega, na? So that's why we are taking in this format. Okay, yes. Fine, guys. So Aditya is saying answer is going to be D for this. Let me check it. Yes, it is correct. Dear answer is very much correct. Aditya, D is the correct answer. D is the correct answer. Very good, Aditya. You are doing wonderfully. I hope you will definitely be selected into this exam as you guys are going wonderfully. Mandeep Kaur, very good. Fine, Arun Kumar. Okay, let us move to the next question. Yes, Gaurav Vajpayee, it is correct. Arun, it is correct. Wonderful. So the flywheel of a steam engine have a radius of gyration of 1 meter. K is 1 meter. M is 2000 kg. Starting torque of the engine is 2000 Newton meter. Kinetic energy of the flywheel after 10 seconds from start is. Yes. Solve it, guys. The kinetic energy of the flywheel after 10 seconds. Yes. First of all, find out the value of I. You know that torque is I into alpha. So torque is given to you. I you can find out like this way, mk square. You will be able to find out the value of alpha. Okay, and once you will be getting the value of alpha, guys, then obviously you know, as you know the equation to be V is equals to U plus AT, you can write omega is equals to omega naught plus alpha times of T, and you will be finding out the value of omega after 10 seconds. So when you will be getting this value, okay, Aditya already answered it. Answer is B. Very good. Answer is B only. So as you know, initial velocity is going to be 0. You will get some value of omega. Then E will be half I omega square. And you will be getting the value of energy. So the value will be B, 100 kilonewton meter. फाइन आदित्य, गौरव वाजपेयी, मनदीप कौर, बहुत बढ़िया गाइस, बहुत बढ़िया, बहुत अच्छे तरीके से कर रहे हैं आप लोग. यस, तो माय डियर, मैं आपको एक बात बता देना चाहता हूं. आई वुड लाइक टू टेल यू वन थिंग दैट कि whatever these examinations are, HAL, HPCL, they are majorly, so they are not asking from every topic. Like some topics they are considerably asking more and more. Like as in theory of machines, the first part, velocity, acceleration, simple mechanism, that part is asked more. Okay, and vibrations is going to be something better than the topics like governor and cams. So when we know these topics are asked more, so it is better to practice more onto that topics. So tomorrow's session will be on vibration. So don't miss tomorrow's session. Tomorrow's session will be based on vibrations. So in vibration, generally student feels that there will be numericals coming more. Yes, chances are there, but numericals will be of that type that you need not to go for any calculators. Okay, in that way they will be asking. Which one of the following statement is correct regarding the flywheel? The flywheel reduces the fluctuation of speed during a cycle. Okay, that question we have already seen. Next question is this: what is maximum speed of flywheel? Having a mass of 5200 kg, radius of gyration is 1.8 meter, I will be mk square. When the fluctuation of energy delta E is given to you as 100,800 and it is equals to I omega mean square CS. You need to find out the mean speed of the engine. It is given. So N mean is also given as 180. You know omega mean is going to be 2 pi N mean by 60. You just need to put the value. Yes. And you need to find out omega max. Once you get CS, CS is nothing but omega max minus omega mean, and you want the answer in N. So N max minus N mean upon N mean. Yes, guys. So solve this one, guys. Solve this one. Satish, the time of class is 11 p.m. 11 p.m. is the time of class. Okay. Yes. Yes, guys, what will be the answer for this? What you will get, guys? Yes. So guys, mean speed is given to you 180 and they are asking you the maximum speed. Obviously, maximum speed cannot be less than 180. It will be more than 180 only. Okay? Yes. So you just need to find out delta n. Find out delta n as CS into n mean. Once you get delta n value, you will be getting the idea that which one can be the correct answer. CS is coming out to be 0.0168. Okay, Arun Kumar, Sanjay, Gaurav Vajpayee have already been answered at A, 181.5. Yes, very good guys. Wonderful. बहुत बढ़िया. So guys, we have covered nearly all the types of flywheel in a way questions can come. Okay? Yes. Sir, but we don't know Newton minute. Dear, it is Newton meter, Newton mm. Not Newton minute, it is Newton mm. Basically, sometimes typing errors are there. It is Newton mm or Newton meter. The maximum fluctuation of energy in a flywheel is delta E is the maximum fluctuation of energy. Yes. Which one of the following is correct? Guys, this question is a homework question for you. And when I am saying homework question, it is for sure that this question is not as simple as you feel. If you see K is the coefficient of fluctuation of speed, many of you may be saying this is the answer. But if you see this, it is I omega mean into omega 1 minus omega 2. If you multiply it with, if you are going to divide it by omega mean, 2 times omega mean, and if you are going to multiply it with omega mean, not 2 times, then you see whether you are getting the answer, whether it is going to be the same I omega square CS. If yes, then the answer will be D. Yes, very good. Many of you have already answered it. It is all of these. All of these will be the fluctuation of energy for sure. Wonderful. So guys, that also we have solved basically. That also we have solved. This also question we have seen. Okay. Now it is asking about the maximum fluctuation of energy is going to be directly proportional to. If N1 and N2 are the maximum and minimum speed, as I told you in my PPT, I am having many questions. Similar question I am skipping so that you guys can try for it. Ramesh Mohan, C is also correct. Okay. When you will be equating it with the, when you will be trying to write it in the form of kinetic energy, it will be coming out to be 2 times of K also. So guys, this is the last question for this session. as we have covered the flywheel topic today, tomorrow with the vibration I will be having some of the questions from CAM and governor as well. So tomorrow's session may be for 1 to 1.5 hours. Okay, tomorrow's session may be somehow longer because I will be covering vibration, CAMs and governor. So be ready for that session. Come with revisions. Here obviously the answer is going to be A, because when you are going to write down the delta E, it is going to be I omega mu square CS. So A or B or C or D, what do you feel? Which one is correct? Delta E. Delta E can also be written as, you know that it is I half I omega max square minus omega min square. This is the origin of the formula. From there we reach to this one. So when you will be writing it, it is coming out to be half I. It is going to be omega max square minus omega min square. So obviously you can write it as 2 pi n max square by 60 minus 2 pi n min square by 60. Yes. So from here you can see 2 pi by 60 is going to be constant and you will be getting the answer. Fine guys, fine, wonderful. So you guys have done it in a wonderful manner. So guys, that one question what we have discussed about, that question which was given in this format from 800 to 1200. If we are going to find out CE for that, then my dear, you can consider it to be complete P theta diagram, and then you need to calculate about, obviously that here 0 and here 2 pi was given. Then you need to calculate about the T mean also, then you will be considering it to be cycle. And then again you will be finding out the area of the cycle, and completely you can do this if they are asking about complete, but I have asked their CS. So I will be sharing the calculation of that question also. So if you guys have any doubt, you can definitely see. Shubhra Jyoti, I am a first year mechanical engineer. First year, sir, do mechanical engineer has any future in automotive engineering? Dear, definitely you guys have the future. Basically in the mechanical engineering, you can go to any of the field of your choice. You can go for automotive also, because even if you want to go for any of the field like GAL, whatever the PSUs are there in oil sector, in power plant, everything is going to be open for mechanical peoples. Okay, the problem is with those who are going for BTech in the specific branches like automobile and all, for them choices are going to be lesser. For them choices are going to be lesser. Like if you are doing the BTech from automobile, you are doing the BTech from production and industrial, then you will not be eligible for all the PSUs. But if you are going for mechanical, you can definitely go to automotive anytime. Even you can go to aeronautical. Definitely options are open to you. But that definitely will depend upon the openings in the companies and whether the companies are coming to your college or not. Okay, that thing will come into picture. But even if you are going in MTech, then Mahindra is coming for recruitment, and Mahindra is an automotive, you know that, automobile company. So guys, I feel we have done a lot of questions today over flywheel. So guys, we will be doing the question from CAM and governor in the next session along with vibration. So meet me tomorrow, and before leaving the session, please like and share. And also I would like to say guys, tomorrow come with the revision of vibration and all the topics which we have done here, so that you can answer all the questions which we will be doing here, which we will be looking at here. So be ready for tomorrow's session. And guys, those students who are also preparing for paper 1, we are soon going to start the classes of project management and all. Okay, yes. So goodbye guys for this session. Thanks for joining again. We will meet tomorrow once again. Goodbye.